Domain and range, input and output, X and Y, all synonyms for the same words. When we're talking about domain and range with a function that is a set of ordered pairs, it's very easy. We just look at our function f here. All of our x values are 3, 5, 8, and 10. So my domain I can list out 3, 5, 8, and 10. My range is all my y values, or all the outputs from function f, 6, 10, 16, and 20. And we'll just make a nice little list of those values. However, if we're dealing with a function or a relation that is a graph may have an infinite amount of points on it, and there's no way to list out every possible x and every possible y. So there's got to be a way to write the domain and range without making a humongous list. We're going to use this circle with a center at 3, -2, and a radius of 4 to show how we can write domain and range of the circle. Now the x values, the domain, is a description of the x's, or how the graph goes from side to side. So an easy way to do this is to find your smallest x value on the graph. So in this case, my smallest x value is right here at -1, -2. But our x value is -1. That's going to be the beginning of my domain. And then my highest x value is on the other side of the circle, way down here at 1, 2, 3, 4, 5, 6, 7, -2. So my highest x value is 7. And this notation shows me that my entire circle is in between -1 and +7, including -1 and +7, because we actually, when we plug in -1 and 7 as x's, we'll get -2 out as our y values. The range, or the y's, are a description of how our graph goes up and down, our y values. I'll do the same thing here. Let's find our smallest y value, or our farthest value at the bottom of the graph, which is right here, which happens to have a point of 3, -1, 2, 3, 4, 5, 6. So our smallest y value is -6, and our highest y value, or the tip top of our graph, is up here at 3, y value 2. So all of our y values go from -6 up to +2. One thing to note, on my domain and ranges here, I've used what's called interval notation, so we can say the range or domain goes from here to here. You could, if you wanted, use notation like this. X is in between -1 and +7. X is bigger than or equal to -1, and x is less than or equal to 7. And the y values, we can do the same thing. Y is in between -6 and +2. I prefer the interval notation so you don't have to worry about the inequality signs. Moving over to the g function, which is an absolute value graph, the domain of this, the description is the graph goes side to side. Notice when I go to find my farthest point to the left, I'm never going to find it because my v keeps going farther and farther left all the time. My farthest point to the right, I'm never going to find it because this keeps going infinitely off to the right. So when that happens, the domain is from -infinity to +infinity. Now notice I've used plain old parentheses here, and that's because I'm never going to hit infinity or -infinity. I'm never going to get there. Whereas on the circle, I most definitely hit the number -1 as my domain. I hit 7 as my domain. So I use the square brackets when I actually hit a value, and parentheses when I'm just getting close to a value. My range on the absolute value graph, its lowest point, we can actually locate it. It's right here at a y value of 1. So we hit 1. And then the graph goes up from there, and I am never going to be able to get to the top of that graph. It goes infinitely upwards. So the range is from 1 up to infinity. Our next graph, the sideways parabola, doing the domain, I can see, oh, my farthest point to the left, my lowest x value is right here at an x value of positive 5. So we hit 5. And then from there, I'm not going to be able to find its farthest point to the right because it goes forever to the right. So it goes to infinity. My ranges from this point on the x-axis, my two branches of my parabola, the top branch is going to go up forever. I'm never going to find the top. My bottom branch goes down forever. I'm never going to find the bottom. So our range is from negative infinity to positive infinity. And lastly, the cubic function. This one, the domain, the x values, because of those little arrows at the ends of this cubic, we can plug in any x value into this equation and get a y value out. Or, we can also think about it, this graph goes forever to the sides. Negative infinity to positive infinity. And the range, same thing, with those arrows on it, goes forever up and forever down. There's our range.